Now let's talk about another scenario. Go into your father class, and here if I try to have something like void show address, okay, and here I will be saying like address of father is like USA. And what if I try to do, I go into our mother class, and inside the mother class I try to have a method with the same name like as we have over here, and try to copy this and pasting over here. Let me just change this to UK so that you guys can have the different version of two same methods. Okay, now if I go over here, let me just remove these things and try to access that method. You can see over here show that there are two show addresses method, and try to access one of these methods with the object of child class. It will give us an error. What is the error? You can see that request for the member show address is ambiguous. What does this mean? This means that if you have a method with the same name into two different classes, then you cannot access that method with the child class object, which actually will give you an error that you are trying to access a method which is actually available two times, in first into the father class and then into the parent class, but the name is same. So compiler is not understanding which version of the parent class you are trying to access. Okay, now if I go over here into our main method and create an object of our mother class, I am going to say object m, and at the same time I will be creating the object of our father class, and I'm going to name it object father. If I try to access object mother show address, and at the same time I'm going to get the object of father and trying to access the show father address, this would be perfectly fine. There would be no error at all. Let me run it. You can see it from here. Address of father is UK, address of father is USA. We have the name like we have used father into mother class object as well. Let me change this to mother, and let me put an ndl over here. Okay, and ndl over here as well. If I try to run it, you can see that address of mother is UK and address of father is UK. This is perfectly alright because we are accessing the same version, same method with the different class name. When it comes to child object will go into father class and try to access that method, and at the same time it will have a same method with the same name as show address into mother class as well. So it will be very ambiguous for the compiler to decide what method are you going to access. For that purpose, in a real scenario, we do not have method with the same name of the parent class, and if you do have those method with the same name, then you don't try to access that with the child class. Okay, I hope that you have understood something out of this scenario as well. Now let's talk about the third scenario. Now let's go back into our slides and see what's the next scenario. Okay, as I have already explained, the derived class does not inherit access to a private data member. However, it does inherit a full parent object which contains any private members that class declared. What does this mean? If I go over here, you can see from here that when a class which is parent class, a child class, and inherit that class, all the properties that exist over here inherited into child class. But child class object does not have access to the private member of its parent class. But at the same time, these members comes as a part of the parent object when we inherit them into child class. But all you can do is see them. You cannot change, cannot modify, cannot use them. Okay, so let's talk about the main thing, which is parent class constructor. till this time we do not have discussed the constructor, that how this constructor is initialized. If you don't have any idea that what constructor is a special kind of method that initialize or create the object of the class. When we create an object of the class, a constructor is automatically called by the compiler if we do not provide our own copy. But if we provide our own copy, then that copy runs when we create a constructor. So when parent, first scenario is when parent class constructor is called. So let's get back into our dev C++, and here let me remove all these things. Okay, I'm going to remove this as well. Let's create a class that will be like class, and I know I'm going to call base class, and there would be a class like derived class. Okay, now if I inherit this base class into our derived class by using that inherited mode, then base. Okay, if I create the object of our derived class, I'm going to name it object D, and if I run it, nothing happens. Okay, because what actually happened here, we do not provide the our own copies of constructor for base class and derived class, and our compiler actually automatically provide the copies for our classes of constructor for our classes when we do not provide the copies. What if I provide my own copy for base class like this? You all know that the constructor should be public all the time. Now let me create that constructor over here. And if I see out here, this is parent class constructor. Okay, let me put the handle over here. And now if I go into derived class, let me declare it public. And I'm going to create the constructor of our derived class. And this is child class constructor. No, we have provided our own copies for the base class constructor and the derived class. Whenever we will be creating the object of these classes, these two copies will run. If I try to run this out, no, you can see that the parent class constructor is called and the child class constructor is called. How this happened? What does this mean? It actually means that whenever we try to create the object of child class, it comes over here and see if there is a base class or parent class that we have inherited into our child class. Then first it will go into our base class and run the constructor of the base class. So what you have learned from this, that whenever we are going to create the constructor of our child class, it will first call the constructor of base class. Okay, it means the object of base class is created before we create the object of our child class. That's how we can use those all properties into derived class, because before using those properties we create the object of our base class with the help of constructor of our derived class. Okay, now if I remove this, then what will happen? Let's run it out. You can see that there is no statement because the compiler have called the default constructor. In this case, because we do not provide our own copy for our base class, that's why compiler called its own copy. Okay, let me undo this. Okay, now what if I create the object of base class first? Base class, obj base class. Okay, now let's see what will happen. Third time, first the parent class is constructor is created, again parent class constructor is created, again child class constructor is and child class constructor is created. How this has happened? The things that happened here over here is that when we first create the object of base class, this is some separate object. Okay, but when we create the derived class object, our compiler also create an object of the base class for our derived class as well. Okay, so if I create another object like over here, obj d2, and let me name it d2. Now compiler will create two object of base class. First one for the derived one class and derived two class. Okay, let me comment this out and you would see that. Okay, you can see that this is parent class constructor, this is child class constructor. This actually, when this line of code runs, this runs because of this object, and when this line of code runs, this is actually run because of this line of code. Okay, so what you have learned out of this, that every time you are going to create a child class object, compiler will also create the object of base class as well. So if you have provided your own constructor for the derived class and the base class, then the first parent class constructor or base class constructor will be called, and after that the child constructor will be called. Okay, I hope that you have understood something out of this. Let's talk about calling the default constructor of parent class. What does it mean? Default constructor means that a simple constructor which is used to create the object of that particular class, and we do not have the customized statement into that cluster. How this happened? If we go over here and instead of writing this, let me just change this and I'm going to create the object derived class. If I create the object D and put the parenthesis with it and now run, you would see nothing has happened, because this time we are actually calling the default constructor instead of our own constructor. We are actually telling the compiler guy that please stop, do not call the copy of our own constructor, but the default constructor that compiler has provided us. But you cannot use this constructor for calling the member of derived class or base class, because this member is actually non-class type. Okay, you are actually creating a separate variable just to initialize object, but you cannot use that variable to call the members of the class or even for the parent class or derived class.